Today, we will be discussing Python functions, a crucial concept in Python. Whether you are just starting with Python or already have some programming experience, functions are an essential tool you must master. So, what exactly is a function? Simply put, a function is a reusable block of code that helps us solve problems, simplify program structure, and improve readability and efficiency. In today's presentation, we will start by defining functions, gradually introducing function calls, the difference between parameters and arguments, the use of return values, and finally, some practical tips. Through this sharing, I hope everyone will gain a deeper understanding of functions. Function definition. Let's start by looking at function definitions. Here is a simple example. In this code, we use the def keyword to define a function named greet. This function accepts a parameter name, and when we call this function and pass in a name, it prints the corresponding greeting message. Key points. 1. Def is the keyword used to define functions in Python. 2. Choose a meaningful name. It must start with a letter or an underscore and can only contain letters, numbers, or underscores. 3. Include parentheses and parameters. 4. Don't forget the colon. 5. Indent to write the main code. 6. Use a docstring to describe the function's purpose. Additionally, a name is a function parameter, acting as a placeholder requiring a passed value. B. The print statement inside the function uses string formatting to personalize the output. This is a very simple function, but it already demonstrates the basic structure of functions. Why use functions? Why should we use functions? Here are three main reasons. Reusability. Functions allow us to extract repetitive code into reusable blocks, avoiding redundancy. Clearer code structure. Functions help modularize code, ensuring each function focuses on a specific task, making the code structure clearer. Abstraction. Functions allow us to focus on solving problems without worrying about implementation details. For example, if we need to calculate the sum of two numbers multiple times, we can write a function to handle this task instead of rewriting the same code repeatedly. Function calls. Now, let's look at how to call functions. Here are three common ways. 1. Functions without parameters. The say_hello function does not require any parameters. When called, it prints a fixed string, hello. 2. Functions with a single parameter. The greet function accepts a parameter name. When called with a name, it prints a greeting message. 3. Functions with multiple parameters. The add function accepts two parameters, x and y, and returns their sum. When we call this function and pass in two numbers, it calculates their sum and returns the result. In the example, 3 and 5 are passed into x and y, and the sum is returned to result. Key points for calling functions. When calling functions, there are a few important points to note. Always use parentheses. Even if a function has no parameters, parentheses are required, otherwise, Python will not execute the function. Arguments can be values, variables, or expressions. For example, you can pass a number, a variable, or an arithmetic expression as an argument. Correct order and number of arguments. If a function defines two parameters, you must provide exactly two arguments when calling it, otherwise, an error will occur. Advanced tips. Here are some advanced tips to help you use functions more effectively. If a function isn't executing correctly, check, is the function name spelled correctly? Are the parentheses included? Are the arguments correctly passed? Parameters versus arguments. Now, let's differentiate between parameters and arguments. Parameter, a placeholder defined in the function definition. Argument, the actual value passed when calling the function. Example. In this example, name is a parameter, while Tom is an argument. Understanding this distinction is crucial to grasp how functions operate. Types of arguments. Here are 3 common types of arguments. 1. Positional arguments. Arguments are passed in order. 2. Keyword arguments. Arguments are specified using parameter names, allowing flexibility in order. The function greet accepts 2 parameters, name and age. When calling greet, the age parameter is assigned 25, and the name parameter is assigned Tom. Output: Tom is 25 years old. 3. Default parameters. Allows a function to use a default value if no argument is provided. In the say_hi function, the name parameter has a default value of guest. If name is not provided when calling the function, it defaults to guest. These argument types provide more flexibility when calling functions. Function return values. Finally, let's discuss how Python functions return results after execution. A function's return value is the result sent back to the caller. Common return cases. Functions have several common return cases. 1. Returning a single value, e.g. computing the sum of 2 numbers. 2. No return value. If a function does not use return, it defaults to returning none. 3. Returning multiple values. Functions can return multiple values, which are packed into a tuple. 1. Returning a single value. Example: the return keyword is used to return the computed result. X plus Y calculates the sum of 2 parameters. Calling add 3, 5, computes 3 plus 5. Return sends back the result 8. The returned value is stored in the variable result. Finally, print result outputs 8. 2. No return value, returns none. Key points: this function does not use return. When a function lacks an explicit return, Python automatically returns none. Since there's no explicit return value, result is assigned none. Print result outputs none. 3. Returning multiple values. Key points: using a single return statement to return multiple values. Multiple return values are separated by commas. Python packs these values into a tuple. The returned tuple is automatically unpacked. Name is assigned the first return value, Tom. Age is assigned the second return value, 25. Output: name, Tom, age, 25. Conclusion. In summary, functions are an indispensable tool in Python programming. They improve code readability and reusability, making problem-solving more efficient.